The broadcast is now starting. All attendees are in listen-only mode.
Hello, everyone. Good afternoon. Thank you for joining our webinar today. I wanted to introduce myself. My name is Ryan Livingston, and I support the U.S. Department of Energy's Federal Energy Management Program and the Better Buildings Initiative. Today, I will be your moderator. So once more, I'd like to welcome you to this June 2019 edition of the Better Buildings webinar series. In this series, we'll be profiling the best practices of Better Buildings Challenge and Alliance partners and other organizations working to improve energy efficiency in their buildings. So we will move to the next slide. More specifically, today we are going to discuss opportunities to improve air management in small and medium-sized data centers. Research has shown that nearly half of all data center IT equipment resides in small and medium-sized data centers. These data centers face unique challenges, but also have immense opportunity to improve air management, thereby reducing infrastructure and energy costs. Although this webinar is focused on small and medium-sized data centers, the areas and principles discussed today could apply to any size data center. Today's webinar will focus on practical solutions for air management in small and medium-sized data centers. Our discussion will focus on air management techniques, practical applications, and lessons learned from Lawrence Berkeley National Laboratory's Center of Expertise on Energy Efficiency in Data Centers, and from Goal Achieving Better Buildings Data Center Challenge partner, Sabey Data Centers. Before we get started with our presentations, I wanted to remind the audience that you will be holding your questions until the end of the hour. Throughout today's webinar, please send in your questions to the chat box on your webinar screen. We will try and get as many of them as we can. Also, today's webinar will be archived and posted to the Better Buildings Webinar Series webpage for your future reference. So, I'm now pleased to introduce our fantastic presenters for today. Our first panelist will be Steve Greenberg. He is a Senior Energy Management Engineer at Lawrence Berkeley National Labs Center of Expertise of Energy Efficiency in Data Centers. So Steve has researched and applied energy efficient building and industrial systems for a variety of clients on 3 continents over the past 36 years. His data center engineering expertise spans over 19 years and includes centers ranging from server closets to supercomputer centers in excess of 15 megawatts. He has been involved in design review, commissioning, and retrofit, and has taught several workshops on data center energy efficiency for the Department of Energy, utility companies, and ASHRAE. Steve holds a bachelor's degree in mechanical engineering and a master's of energy and resources from the University of California at Berkeley. So Steve will be followed today by our second presenter, John Sasser, who is a Senior Vice President of Operations for Sabey Data Centers and our Better Buildings Challenge partner. With over 20 years of management experience, John is responsible for developing the conceptual basis of design and operations for all Sabey data centers, managing data center client relationships, overseeing construction projects, and planning for electrical utility capacity. With a background in engineering facility, John specializes in ensuring Sabey's data center solutions meet customers' evolving needs. John is passionate about energy efficiency, resulting in approximately $5 million in awarded utility incentives, along with an Energy Star score of 100 for Sabey's Intergate Quincy data center. John also happens to be an inventor. He received a patent for a mobile commissioning assistant to better test data center airflow. Prior to joining Sabey, John worked for Capital One and the Walt Disney Company. He has spent 7 years with the Navy Civil Engineering Corps. John has also passed past president and founding member of the Western Washington State capital of AFCOM, a leading international data center operations industry group. So we will be looking forward to hearing from John and his experiences at Sabey a little later. I'll add that the Department of Energy's Better Buildings Initiative and Better Buildings Data Center Challenge is very appreciative to be joined by our leading experts from our national labs and industry partners on the forefront of energy efficiency, like Steve and John today. Thank you both for being here, gentlemen. So, without further ado, Steve, when you're ready, please take it away, and next slide, please.
Good afternoon, everybody. Next slide, please. All right, so I'm going to briefly describe air management opportunities in data centers and share with you some of our own experiences at the Lawrence Berkeley Lab. And so in the early days, we had a data center that had what some of you may have experienced, which was generally the data center was cold, but there were hot spots everywhere. We had fans used to try to keep equipment cool. We had put in some very high flow floor tiles in an attempt to get cool air to where it was needed. Next slide. So the problems of air management that need to be dealt with are air going where you don't want it and not where you do want it. And that's the basic problem of air management. It simply means forcing the cool air to go where it's needed and preventing it from mixing with the hot air. So we have problems of bypass air and recirculation air, and the solution is better air management. So the very first step is using hot and cold aisles. As the right side of the slide shows, the blue arrows are the cool air coming up through the floor. The red arrows are the hot air coming out of the IT, out of the computing equipment, and those aisles alternate so that you have cool air coming up and going into both racks and then coming out of alternate sides of the racks to form a hot and cold aisle arrangement. And there are a variety of techniques that I'll get into that describe how to better isolate the hot and cold air. And the benefits from those include energy savings from reducing the fan energy, improving the efficiency of the air conditioning system. And in doing so, there are two big benefits, one of which is a better environment for the IT equipment, and the other one is increased capacity of the cooling system. Next slide. It's the poll, so please vote on this. But if you've never been, yeah, there you go. There's a question for if you haven't been in a data center. So everyone is supposed to respond to this.
Yeah, I'll jump in here, Steve. This is Ryan again. We just wanted to poll the audience today and see what their experience with data centers has been to date. So we'll give everyone a few moments to respond, and then we will post the results. Thank you for your participation.
All right, so that response doesn't surprise me. Most people who have been in a data center have been in a cold one, and a cold data center is the sign of opportunities for improved air management. Next slide. So again, the basic concept of good air management is to keep the hot and cold airflow separate, which is exactly the opposite of what one tends to do in normal office space where mixing is a good thing. But here, mixing is a bad thing. And so the ideal is shown in this illustration where the cold air is supplied to the rack. It goes through the rack. It doesn't mix and then it goes back to the cooling equipment. Next slide. All right, but in reality, we have two problems. We have bypass, which is cool air that goes back to the cooling equipment without having run through the IT equipment. And then we have recirculation, which is hot air going back through the IT equipment without having been cooled by the cooling equipment. And you can have bypass and recirculation at the same time. Most data centers do have that to a certain extent. You can have it external to the rack as shown, and you can also have it internal to the rack. Both are bad. The recirculation is worse in terms of IT equipment getting air that's warmer than it should. Next slide, please. All right, so bypass air, again, it's common in pretty much any air-cooled data center. If you have more supply airflow than you need, you'll tend to get more bypass. Misplaced perforated tiles, like as shown there on the right, a perforated tile in the hot aisle, that will result in bypass. Cable penetrations are a common source, and airflow velocity that's too high coming out of the floor tiles. Next slide. Okay, recirculation air, also bad. This is where air that's been heated by the IT equipment recirculates back to the inlet of the IT, and that's caused by too little supply airflow, rarely, but that definitely will increase recirculation. Lack of blanking panels inside the rack, gaps between racks, and short equipment rows where the air recirculates around the end. Next slide. Okay, so this is looking down at the floor inside a rack, and this is a common problem. Cable penetrations through the floor not being properly sealed, as on the left, and on the right, you can see the cables have been neatly bundled, and there are these black pillow-like objects that block the excess cutout area to reduce that airflow, bypass airflow problem. Next slide. All right, so here's an example of blanking panels, which are simply filling the gaps within the rack where there's no IT equipment. All of those should be closed off with blanking panels, and otherwise you'll get recirculation within the rack and raising the inlet temperature to the IT equipment. Here's an example of where we fixed that problem, and it dropped the inlet temperature for the IT equipment by about 20 degrees, both at the top and middle of that rack. So blanking panel, very mundane. Some people can't be bothered to deal with them, but it makes a huge difference in the performance of the cooling system. Next slide. All right, so restrictions and congestion. So again, good air management is about getting the air to go where you want and not where you don't. And if you block the airflow where you want it to go, then it can't get to where it needs to go. And so on the left is an example of congested floor and ceiling cavities packed full of cables, probably a lot of which are no longer in use. And on the right is a much better example of those spaces that then enables the air to flow freely where it should. Next slide. Okay, so balancing is necessary to get the optimum airflow. Whenever significant changes are made in the data center, it should be checked and balanced as necessary. One of the very early steps of this process is to make sure that there are no perforated tiles except in the cold aisles. Next slide. All right, so too much open tile area is at least as much of a problem as too little. It'll result in very low underfloor pressures, which will make it difficult for the air to for adequate airflow to reach the tops of the racks. So whenever you see wide open tiles, that's an indication that things are probably out of balance. One can measure this either with temperatures, as is shown here on the lower right of this slide, or in a more sophisticated way with pressures. But the bottom line is the IT equipment needs to get an adequate supply of cooling air. Next slide, please. All right, so here is a elevation view of a row of racks, and this is a very common distribution problem. You've got air that's colder than it should be in the center. At the bottom center of the rack, you've got of that green band of temperature that's in the proper range, in the recommended range, and then at the tops, and typically worse at the ends of the racks because the hot air comes around the end as well as over the top, you've got areas that are too hot. And then you've got bypass air there at the bottom escaping around the ends of the aisles. Next slide. Okay, so here's a better approach to help improve air management, and that is you've got the underfloor, the typical underfloor plenum where the cool air is supplied. It comes up into the cold aisles, it passes through the IT equipment, and then rather than returning just through open space, we use the above ceiling space as a return air plenum. We put perforated grills above the hot aisles to facilitate that airflow, and then the CRAC or CRAW units, that's computer room air conditioner or computer room air handling units, pull that air out of that plenum and cool it for return to the underfloor space. Next slide. And then there's a whole range of barriers that can be put in a hot aisle or cold aisle to force the air to go where you want it to and not where you don't. And there's some simulations at the bottom, and these can be done again in the hot or cold aisle. One thing to remember is that putting barriers in a data center may block access to fire and smoke detection and suppression systems, and so any changes need to be done in coordination with your fire authority. But they can be very effective. Next slide, please. So here are some examples. Strip curtains. These are the ones like you see in a cold storage. They also work very well for data centers. Many data centers use them. Next slide. And so the concept again is better isolation of hot and cold air. And so this is just an elevation view showing how that works. You put the barriers between the hot and cold aisles, and also at the ends of the aisles to direct the air. Next slide, please. Okay, so here's a cold aisle containment example where you put basically a lid on top of the racks in the cold aisle, and then also doors at the ends, and that keeps that air from becoming bypass air. We did a containment study and showed that we could get fan energy savings on the order of 75%. Next slide. So what we did was we put in a temporary, it was an experiment, so we put in this temporary barrier and realized that we could, we only slowed the fans down from 100% to basically 2/3, and but because of the Cube law relation between flow and power, we saved 3/4 of the fan energy and fully met the cooling needs of the equipment. Next slide. So it's important to remember that what matters is the air temperature entering the IT equipment, and ASHRAE, the American Society of Heating, Refrigerating, and Air Conditioning Engineers, has in in collaboration with all the major IT manufacturers, come up with a set of thermal guidelines with a recommended range and an allowable range. And one should always shoot for the recommended range, but when you look at that range, it's, you know, a low of 64 degrees roughly and a high of roughly 81 degrees Fahrenheit, such that the so-called cold aisle should be, you know, a comfortable temperature for people, making the hot aisle very warm and uncomfortable. And that's normal operating, and the IT equipment will be perfectly happy there. So keeping in mind that range. Next slide, please. So what happened was when we did that cold isolation is the three temperatures, low, medium, and high, which are shown on the left as the blue, pink, and yellow lines, they converged and dropped in temperature to where they were below the bottom of the recommended range. And so what that allows one to do is to raise the supply air temperature of the cooling air and still easily meet the cooling requirements. And in the process of raising that, the cooling system and plant can operate more efficiently because it has a lower thermodynamic lift in order to make those temperatures. Next slide, please. So here's some more examples of containment. Here's a cold aisle containment with a hard lid and doors at the end. On the left side, there's a hot aisle containment. This is an APC arrangement with in-row cooling in lieu of cracks or craws. And then there's some heat shrink tiles on the right. That's where if there's a fire in the space, they soften and drop out so that the fire detection and suppression system can function normally. Next slide. All right, so in summary, what are we trying to do with air management? We're trying to isolate the hot and cold air streams. And there are various ways to do that. A hot and cold aisle with good isolation is an effective way. And if we reduce the bypass, then we can supply less airflow and still meet the IT needs. And in reducing that airflow, we can save significant fan energy. Likewise, we can raise the air temperature if there's no recirculation air artificially raising the temperature of that air being delivered to the IT equipment. So the chillers or cracks will be more efficient because they can operate at a warmer temperature. And if there's either airside or waterside economizer, those can operate for many more hours and deliver more hours of compressor-free cooling during the year. So it's a win all the way around. The cooling system capacity and the ability of the raised floor system to deliver cooling are increased with air management. You can get closer to the rated performance of the cooling equipment with good air management. And the other thing that's important to remember is the IT equipment will be happier because it's getting a more uniform air temperature delivered to it, and fewer pieces of equipment will be outside the recommended range. Next slide. All right, so there are other methods than underfloor air distribution for getting cooling air to the system. Those include row-based cooling units and rack-mounted heat exchangers. These are basically moving the cooling closer to the IT equipment, making a closer coupled system, which improves the isolation and thereby the cooling system performance. Next slide. So here's an in-row based cooling. This is now a plan view. This is an example of this is the APC in-row cooler, where these cooling modules are placed in the row next to the rack, and the hot aisle is contained. The hot air goes right through the cooling system, then back out, and the main data center space is basically cold, a cold aisle, if you will. And there's no, you can do this with no raised floor. There's no the airflow goes in a horizontal loop instead of a vertical one, if you will. So there's no above ceiling plenum, and there's no below floor plenum in this arrangement. Next slide. Okay, so you can also put so-called rear door heat exchangers on the backs of the racks, and they're both passive and active versions of those. But they all work basically the same way. There's some liquid, it might be cooling water, it might be refrigerant that flows through those coils, and the hot air from the IT equipment passes through those coils, cooling it back to a neutral temperature, and then it can go straight from there into the next rack. So this is where the hot aisle, cold aisle, everything outside the racks is the cold aisle basically, and the hot space is just between the IT equipment and the heat exchanger within the rack itself. Next slide. All right, so reviewing again, various techniques. Sealing air leaks in the floor, like cable penetrations, preventing recirculation with blanking panels in the racks and blanking off any space between the racks, under and above the racks, as well managing the floor tiles, especially no perforated tiles in the hot aisles, and then otherwise improving the isolation of the hot and cold air with plenums, strip curtains, or complete isolation, doors at the ends of the aisles, and so forth. And the impact of that can be very significant. You can reduce the supply airflow with saving most of the fan energy. You can increase the temperature of it as well, which improves the efficiency of the system and plant, and you increase the capacity of the system, as well as making your IT equipment happier, because you're better complying with the thermal guidelines. Next slide, please. All right, so another thing that I should mention is that at the Center of Expertise here, we're working on air management packages for targeting small data centers, but the idea is that there are a number of packages of air management strategies that are generally cost-effective, and sort of pre-packaging them helps especially small data centers figure out a retrofit strategy that is likely to be very cost-effective. So we're doing a number of computer models of selection of strategies. We'll estimate the energy savings on a normalized basis, and then we'll put out lookup tables with the existing strategy and then potential retrofit strategies. And this fan energy performance is an example of how we can get that information out there. So the reference, you're using 100% of the fan energy, and then these 5 packages do a number of things that will reduce the amount of airflow needed and or improve the fan energy performance. And you can see that the overall fan energy dropping, to as much as 10% of the original energy. So that's just a very small example of the various strategies that we'll be looking at and disseminating right around the end of this calendar year. And you'll be able to find it on the Center of Expertise for Energy Efficiency and Data Centers website, which is listed there. Next slide. There's my contact information. And next slide. Okay. Thank you, everyone, for your attention.
All right, thanks, Steve.
All right.
Sorry, go ahead, Ryan.
Oh, sorry, John, I'll jump in real quick and just say yes. Thank you, Steve. That was excellent. I'll do a quick plug again for questions. Feel free to send your questions into the webinar chat box during the presentations today. We're collecting them now, and we'll go through them during the Q&A period. So without any other delay, our second presenter, John Sasser, please go ahead.
Thank you, Ryan. Next slide. So again, this is John Sasser with Sabey Data Centers, and just to let people know who we are. So Sabey Data Centers is a data center real estate provider. Primarily, we do wholesale colocation. For those of you who are not familiar with colocation, essentially what a colocation provider does is provides the facilities, including the power, the cooling, the physical security, for customers to put their IT equipment in. And so in the wholesale colocation model, there's essentially two things that our customers pay us primarily. They pay rent, and the rent is based on a per kilowatt basis. So again, it's different than the traditional commercial real estate office where you're paying per square foot. Here, you're really leasing the capacity. You're leasing the power and the cooling capacity along with the space to put your IT cabinets. And then in the wholesale colocation model, the second major payment that you pay to the provider is the electricity. And the electricity is based typically on the metered electricity use, along with the cost for the HVAC and other losses that are required to power that equipment and keep it cool. So again, Sabey Data Centers, we are a colocation provider, a data center real estate provider based in Seattle, Washington. We have campuses in Central Washington, our Indirect Columbia and Indirect Quincy campuses. We have a campus in Ashburn, Virginia, which is just outside of DC. And we have a 32-story building in New York City at the base of the Brooklyn Bridge. Next slide, please. So when I looked at solutions for airflow management for small and medium businesses, one idea that came to mind, which while admittedly is a little bit self-serving, is, hey, just migrate it to a colocation provider. And I say that, you know, there's a couple of reasons I say that. One is, you know, as with a lot of outsourcing, it allows you to work with a provider who specializes in that. And a lot of the co-location providers you'll find operate with very high efficiency and reliability because, again, we focus on operating data center facilities. That's all we do. When you look at, I also realize, of course, that this is more of a strategic decision. This is not something you can go in and make a decision one day, hey, I'm going to outsource everything and go to co-location. It's a strategic decision. But if it is something you're looking at, say you're at end of life at one of your facilities and you need to do a refresh or expand or build a new one, keep in mind that, you know, not all co-locations are the same. Generally speaking, I'd say over the last few years, most have been getting more efficient, but you know, some have a greater focus on efficiency than others. And when you talk to those co-location providers, you may want to ask questions about their operational approach and their design approach to efficiency and what results they've seen in their facilities. As an example, one of the things that we do is we actually require our customers to use containment. So Steve talked earlier about the benefits of hot aisle, cold aisle containment. We've required hot aisle containment as part of our approach since 2008. There's always going to be some benefit in doing containment, but there's a greater benefit if everyone and all cabinets within the data hall use containment. So if a co-location provider says, sure, you can do containment, that's not going to be as effective from an energy standpoint as, yes, you must do containment in that facility. And there's other approaches besides hot or cold aisle containment, but you know, containment is certainly, I'd say, a best practice. The other thing that co-location providers can do is they provide what's called remote hand services. So these are typically services related to the equipment that are not involved with any sort of programming, that sort of thing. It's more physical services. So very often server admins do that kind of work. So in a lot of places, that's an IT function where you have facilities that are taking care of the air conditioning system and the electrical system, that sort of thing. And then you have IT that is racking and stacking equipment, installing the cables, installing the blanking plates that Steve mentioned. And even, containment might go more on the facility side. But as a co-location provider, and most co-location providers do this, very often we offer these remote hand services. So, let's say your server admins don't want to be bothered with blanking plates or, sealing up some of the gaps between or under cabinets. We can take care of that for you. And we have a lot of practice doing that for various customers. So we have a lot of the solutions in mind. Next slide, please. So in the latest Uptime Institute survey, they found that the respondents indicated the average industry PUE is 1.67, and that's a little bit higher than the 2017 results. But generally speaking, over the years, the PUE has been going down. So I think most people on the call may know what this is, but just in case, PUE is power utilization effectiveness, and essentially it's a measure of the energy overhead. So it's the total energy used by the data center facility divided by the amount of energy that's used by the IT equipment is essentially what that ratio represents. So ideally, you want that to be as close as 1 as possible. A PUE of 1 would be perfect. It would mean all of the energy going into the facility is actually being used by the IT equipment. So our most efficient data centers average an annual PUE of 1.13. Those are in our Central Washington facilities. And over our entire portfolio, our weighted average annual is 1.32. So you compare that to the industry average that the Uptime found of 1.67, we're doing pretty good. And part of that kind of going back into the co-location industry is you've seen a lot of new co-location data centers over, say, the last 10 to 15 years especially. And the more recent data center builds also tend to be more efficient. There's more efficient UPS modules being used. There's Economizer is used as part of the package, and you're seeing a lot of people doing some of the things that we've been practicing really since 2008. So since 2008, we've required hot aisle containment. So our designs are based on hot aisle containment. All of our data centers use some form of economizer, and the form we use may vary depending on the climate. So in Seattle, we use a lot of airside economizer, direct evaporative cooling. Central Washington, we use a lot of indirect evaporative cooling. And we use waterside economizer in New York. So that's just an example of the different economizer strategies one may use in different environments. But in each of them, we're using some form of economizer in our data center. In all of our data centers, we use variable speed fans, and the fan speeds are controlled based on differential pressure. So essentially what we're doing there is we're trying to match the amount of fan energy we use, the amount of airflow that is being moved through our air handlers, with the amount of air that's being moved through the servers by the server fan. So that's that ideal situation where you're moving just as much air as the server fans are moving, and you're not seeing the bypass and the recirculation air that Steve mentioned in his presentation. Now that we don't meet that ideal, but we come pretty close in a lot of our data centers to eliminating that bypass and recirculation air. Another practice that we've been doing since 2008 is we build on slab. We have no raised floor, and that simplifies management. And this kind of goes back to the first bullet that you see there, the hot aisle containment required. If we didn't require hot aisle containment, we would need some means of getting the air right in front of the server racks. By using hot aisle containment, we can simply flood the room. And so that removes a lot of the complexities associated with the raised floor, the management of the tiles, the delamination, what's going on underneath the raised floor. There's advantages to raised floor, but if you can simplify it and move it out of the equation, you can also increase some of the efficiency, because there do tend to be some losses involved in pressurizing that raised floor and trying to get the air to the right place. And of course, I mentioned the high efficiency UPS modules. All of the recent UPS modules we have are 96% plus efficiency, and that's in double conversion mode. Next slide, please. All right, indirect evaporite economizer cooling. So I mentioned in Central Washington, we use indirect economizer cooling. And so essentially how this works is we are adding moisture to the outside dry air that cools the temperature of that outside air. And we use a heat exchanger that transfers that heat between the data center air and the outside scavenger air. Again, we use that in our Central Washington facility. This diagram also shows, similar to some diagrams Steve showed, that ideal situation where you're flooding the room with cool ambient air, but not cold, just like 70-degree air. And in the hot aisle, it is very hot. We have measured temperatures of 100 degrees in our hot aisle, and that's okay. That's what they should be. Next slide, please. So I mentioned solution one, move to our data center. Solution two is, of course, more likely in most people's short-term view, which is improve the existing data center. And I'm not going to go through all of these in detail because Steve covered them Steve covered them really well in his presentation. But I'll touch on a few. So we talked hot aisle, cold aisle, blanking plates. So network switches. So network switches are notorious, and I'll address that in another slide. Cable management, containment, system controls, ducting and controls. So let's go into the next slide, please. So switch airflow management. So switches, those top of rack switches and other switches are notorious in not doing the traditional front to back airflow. So in your ideal case, and as is the case with most servers, they draw in air in the front and they discharge it in the back. Many cases, switches don't do that. Sometimes they will go side to side. Sometimes they'll pull it in from the back, the hot air, and discharge the even hotter air into the front. So there are commercially available solutions for that sort of thing. The first solution is if you can talk with your network engineer and have them order a switch that draws in the air from the cold aisle and discharges it into the hot aisle. That's going to be the simplest solution. But there are some commercially available solutions that will help with this particular issue. Next slide, please. Cable management. So Steve showed some pictures of underfloor cable management and above ceiling cable management. You should also think about in the back of your cabinet. So if you look at the cabinet on the left especially, you see the cables are all over the place, and that's going to potentially put some back pressure on the server fans, and they're not going to operate as well. So especially if your bypass air control is not perfect, you'll get more recirculation air if you have poor cable management and you're just not going to circulate air as well. So what you want is you want nicely dressed out cables, and if you look at the cabinet on the right, at the top part of the cabinet anyway, you'll see that they're much more organized looking, and they're not going to block that exhaust air quite as much. Next slide, please. So hot aisle versus cold aisle containment. So we talked a little bit about that, and people tend to have a preference of one over the other, potentially depending on their experience. My opinion is that cold aisle containment tends to be best suited for retrofits. Say you already have a raised floor environment, you want to retain that, you want to do some containment, but you can't really redo your entire HVAC system. Doing something like Steve showed with the lid over the cold aisle and doors at the end of the cold aisle may be a very good solution for that. We do hot aisle containment in all of our new data centers. And what that allows us is, in addition to the efficiency, it allows us a great deal of flexibility. So if you contain your cold aisle, you're designing that cold aisle typically for a certain amount of airflow. And you're not going to get more than that amount of airflow. So that pod of cabinets, you have a certain amount of airflow that you can support. In a hot aisle contained environment, you have much more flexibility because you can see here that you're flooding the entire space. You don't have that underfloor restriction, or even if it were a ducted restriction of how much supply air you can get to the cold aisle. Your primary restriction is going to be in the return ceiling plenum. And we can design a pretty tall return ceiling plenum with not a whole lot of restrictions. So again, you're trying to have the fewest restrictions, and that's going to get you the best flexibility in terms of how much air you can deliver to those server cabinets. So that's why we prefer hot aisle containment. Next slide, please. Controls. So one of the benefits you're going to achieve when you use hot aisle containment and Economizer is that you can expand your the amount of time that you're on free cooling and reduce your fan energy. So somehow you have to control the fans to get to the appropriate speed. And I mentioned earlier, we use differential pressure control for that. In that strategy, what we're trying to do is we're trying to achieve a certain differential pressure set point where the hot aisle is slightly negative compared to the cold aisle. So if there is any bypass airflow, it's going from the cold aisle to the hot aisle and not creating hot spots, but you want it to just be slightly negative. And what we found is when customers install more equipment, they turn it on, our fans automatically adjust to compensate, to maintain that set point. So they'll speed up slightly to maintain that set point. And, similar if, someone takes a piece of equipment out, our fans will match the airflow required by the servers. Next slide, please. And that is the conclusion of my presentation. Thank you all for your attention.
Okay. This is Ryan again, everyone. Great presentation, John. Thank you. We're going to now proceed to our Q&A portion of today's webinar. See what kind of questions everyone has entered. Again, if you've been holding on to your question, feel free to put it into the webinar chat box at this time, and we will attempt to address it for you. Okay. So it looks like we have a few questions for Steve here. The first I will ask of him, generally, what's the most cost-effective way to isolate hot and cold aisles when you already have raised floors?
Right, that's a really good question, right? Because most of the data centers, the new ones tend to be pretty well set up, and the existing ones are all over the place. And so what do we do about all these existing data centers? Most of them are just raised floors. And I would say that the slide I showed with the strip curtains is the most cost-effective way. It's not as effective as doing a hard enclosure, either on the hot or cold aisle, but doing it gets most of the savings, and it's a lot less expensive. You can also do variations in order to make your fire authority having jurisdiction happy, including curtains that drop down, either based on temperature or fire alarm activation, and so there's a lot of things to play with there, and you can do either hot or cold. The advantage to hot is, as John pointed out, most of the space is the cold aisle then, and so more of the space is at a comfortable temperature. But you can do either hot or cold IL containment. Just hopefully that answers the question.
No, great question, great answer. Let's see, I think we got one or two more here for you as well, Steve. Yeah, kind of again along the themes of cost, could you roughly estimate the cost to implement the cold IL containment via the hard top enclosed method that both you and John touched on? I suppose that depends on a few factors, but generally?
Yeah, it depends on a lot of factors, and so there's probably, you know, an order of magnitude variation in cost for that, depending again on, I would say, as much on satisfying the fire safety requirements as on getting the enclosure in place. It also has to do with whether you have uniform rack top heights and so forth. And then there are quite a number of manufacturers out there who have products that can provide that enclosure system. And so I'm somewhat loath to put any numbers out there. I would say, you know, contact some vendors and get some quotes, but also, you know, be sure to be in touch with your fire marshal about what would be acceptable.
Very good point. Yeah, I don't want to make any changes there that will get you in trouble with that.
Right. The worst is to put something in and then have to take it out again.
Then you're guaranteed a higher cost for sure. We'll give Steve a break here for a moment and shoot some questions John's way. John, here's a question. Do some UPSs use bypass in normal operation, and thereby making them even more than 96% efficient? Are you aware of any that operate this way?
Yeah. There's a number of UPSs out there that are offered by various manufacturers that run in, just as the question suggests, in a form of bypass. A lot of people like to call them eco mode, and usually the manufacturers have you know, some other name for it. And the theory of the operation is that they're primarily bypassing the electronics in their normal operation. And if there's a voltage disturbance, they will quickly go to a fully protected mode where the electricity is running through the electronics. And you know, so those have been out for at least 10 years. Again, a variety of manufacturers do that. And yet I hear different things in the industry about those UPSs. So I think it may depend on your topology and may depend on your you know, particular circumstances in terms of whether you would actually want to adopt something along those lines. For example, we do not use any of those eco mode UPSs, and the reason we don't use them is a lot of our topologies use downstream static transfer switches, and there can be coordination challenges between that bypass eco mode and those downstream static transfer switches, where you get unintended transfers. So, but they do exist, and they can approach 100% efficiency in bypass.
Very interesting. Very interesting, and interesting as well that you take a little bit different of approach. So again, kind of going back to what Steve was saying, you know, it depends on your situation. Many solutions. Let's see here. Another question for John. Do your I guess Sabey's, does Sabey's AHUs, I assume that's air handling unit, use supply air temperature control?
Yeah, so I didn't go into this part of our control strategy, but the way we control the supply air, the discharge air from our air handlers, is we manually set that, have a set point where our air handler seeks to achieve a certain temperature. So we don't actively control to say the temperature sensors in the space. We'll set a discharge temperature of, let's just call it 70 degrees from the air handler, and each of the air handlers is trying to achieve 70 degrees. And and with that, and with using containment, and with using differential pressure to control our fan speed, we find that that really provides a nice stable temperature within the cold aisles of our hot aisle contained data centers, which is a little different than, you know, a lot of people think. A lot of people think that you're controlling to a temperature sensor like you would, say, in an office, where if it gets a little warmer, the fans kick on, and cools down, they turn off. That's not really how we control it. Those air handlers are running all the time. They're making that 70-degree air all the time, and our fans ramp up and down slightly to maintain that differential pressure set point.
Got it. Good answer. Yeah, about maintaining that constant, I think. Okay. Thank you, John. We will see. We have about 3 minutes left here to close, so I think I'll go back to Steve with maybe one or two more questions. Steve, to you. If it's a small data room, and this is what we're talking about today, small and medium-sized data centers, that is made up of a single row of racks, is aisle containment still feasible?
Yeah, that's a great question. So for your really, your server closets or whatever, and the answer is yes, there are still ways to do that. And one of them is, so like the rear door cooling scheme can be applied all the way down to a single rack. That's a strategy. There are also hot side chimneys that are an attachment to the racks that direct the hot air to the return plenum, where it'll be cooled by the HVAC equipment and return. So the answer is yes, there are air management strategies, all the way down to a single rack, but certainly a single row.
Perfect. Good to know. See if we have time for maybe one more question. There are a few more questions, but I think I'm going to move to our last couple slides here today. Your questions are very much appreciated, and they can be directed to our presenters today at a later date as well for further follow-up. We're already on the next slide here. In closing, I'd like to share that we'll be having the next instance of our Better Buildings webinar series planned for Tuesday, October 1, again at 3 p.m. Eastern, entitled Straight Talk, talking to multifamily tenants about utility benchmarking. So this webinar will identify strategies for obtaining tenant consent to share their utility data. We'll also explore ways to engage multifamily residents about the benefits of energy efficiency and upgrades. So please register for this webinar now. The ability, you are able to do so on the Better Buildings Solutions Center website. Next slide. Want to highlight the upcoming 2019 Better Buildings, Better Plant Summit. This will be taking place next month in July, July 10th through 11th, Arlington, Virginia, which is the DC metro area. Pre-conference activities will be taking place the day prior on July 9th, including a tour of two of our local and goal-achieving Better Buildings Data Center Challenge partners, Digital Realty and Iron Mountain. The tour is a full-day event with transportation and lunch provided. So, should you be wishing to learn more about the tour or the summit at large, please go to the Better Buildings Solutions Center website, where you can browse the agenda, you can review detailed session descriptions, read about keynote speakers and events, and much more. So please utilize the link that's provided in the slide to check that out. We hope to see you there. And next and last slide. With all this in mind, I once again would like to sincerely thank our presenters, Steve and John, today very much for their time and expertise shared. Following today's webinar, please feel free to, again, contact them directly with any questions you may have, or in the case that we weren't able to get to your question that you had entered. If you'd like to learn more broadly about the Better Buildings Challenge or Better Buildings Alliance, please check out the Better Buildings Solutions Center website, or feel free to contact myself or my colleagues Kendall or Megan with their emails here. I will also encourage you to follow our Better Buildings Initiative on Twitter for the latest and greatest from DOE, the Department of Energy, and all our partners. Lastly, as a registered attendee of today's webinar, you will be receiving an email notifying you when the session is archived and available online for your reference. Thank you, everyone, for attending today's webinar on air management solutions for small to medium-sized data centers. Have a great afternoon and the rest of your week. Thank you.